Hello everyone, welcome to the session on the course Energy Engineering. I am Satish H, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So this session we will try to cover the topics or the concepts which are necessary for the solving the numericals or the problems which are based on hydroelectric power plant. So in this video lecture, I am going to cover the topics. The topics are listed out here. The first one is hydrographs. Okay, here we will see what do you mean by the hydrographs. Okay, so it is basically a graph. Okay, and the like in the y-axis we have a discharge and the x-axis we have a time. The time can be taken in terms of the months, okay, or the years or the days, etc. Okay, so we will see, okay, so how to draw that graph, okay, when the data is given, okay, from the problem. So the next topic is flow duration curves. Okay, so the flow duration curves is also it is a graphical representation. On the y-axis we have a discharge again, and the x-axis we will plot the percent of the time. Okay, so that is called as a flow duration curve. Okay, so like with the help of a sketch, okay, we will try to understand what do you mean by the flow duration curve. Okay, and then later on we will discuss about the mass curves, and then the unit hydrographs, and then some of the numericals which are based on, okay, these concepts like hydrographs, okay, and flow duration curves, etc. So coming to the first topic, that is hydrographs. Okay, so here this is the graph which shows on the y-axis we have a discharge. Okay, so discharge is measured in meter cube per second. So on the x-axis we have a time. Okay, so graph shows discharge of flowing water with respect to the time. Okay, so what is the discharge with respect to the time? That representation can be given, okay, with the help of a hydrograph here. Okay, so here the time period can be taken in terms of the hour, day, week, or month. Okay, so the time can be anything, like you can take it in an hour, or you can take it in a day, or you can take a discharge, okay, over month, or you can take a discharge over the week, etc. Okay, so and then this depends on what are the characteristics, or some of the characteristics of the catchment area. Okay, and then precipitation over the catchment area. Okay, so how much rainfall that happens, okay, over that catchment area. Catchment area is, okay, so it is a area where the rainfall happens, and then from the water which is collected from all this catchment area comes into the river. Okay, so that is the precipitation is the how much rainfall that is happening over that catchment area. Okay, so coming to the graph here, so here I have taken some example here. On the x-axis we have a time here, and then on the x-axis we have in terms of the months I represented a time. Okay, A means April, May, June, July, August. Similarly, until 12 months. Okay, over 1 year. Okay, so we have taken the time. Okay, it is on the x-axis we have a monthly. Okay, so the time. So on the y-axis we have the discharge. Okay, suppose if you take the April month, what is the discharge you have? You can locate that point over this graph. And similarly, May. Okay, what is a discharge we have? Similarly, June, what is the discharge we have? Okay, so if you plot, all these discharge with respect to the months, okay, and then you will kind of get this kind of a curve here. Okay, so if you look at this curve, okay, there is a peak, okay, that is represented with C, and then we have a point A and then point B. Those are lower points. Okay, so this region is called as the accretion side, and this is called as a recession side. Okay, so during this period there will be a no rainfall, for example, and then the discharge available in the river, okay, or the stream is very less. Okay, so that will be constant. And then during the month of June, July, August, okay, and September, during that time when the rainfall happens, gradually the water level in the stream or the river increases. Okay, so that is represented with this increasing trend of this curve. At the sea you have a peak like a load, okay, I'm sorry, peak flow available, that is discharge available, okay, and then gradually as the rainfall decreases, okay, so during the months of in the winter seasons like November, December, etc., so gradually there is a decrease in this trend, okay, and then again this cycle repeats over the time, okay. So basically what does this hydrograph represent is, okay, over the period of time how much is the discharge is available, okay, that is represented with the help of an hydrograph here, okay. So coming to the next topic, that is flow duration curves, okay. So this is also a graphical representation. We don't change the y-axis component here. The parameter on the y-axis in the hydrograph is the discharge, okay. So we keep the same thing. The discharge is on the like a y component of this flow duration curve, whereas on the x-axis we have a time. Okay, in the previous case also we had a time, okay, but here it is not only the time, it is a percentage of the time, okay. So how much discharge is available at the 10% of the time, okay. So and then how much discharge is available at 20% of the time, okay. Similarly up to 100%, okay, how much discharge is available. Those points can be plotted here on this like a graph here, so that with the help of the curve, okay, we can plot this flow duration curve, okay. So it is flow available during a period versus fraction of the time. This fraction of the time is important, okay. So and then draw with the help of an hydrograph, okay. The first we draw the hydrograph, the data from the hydrograph is taken and then we try to plot this flow duration curve, okay. Flow duration curve is dependent upon the hydrograph, and then we have a area under the curve, okay. Here in the sketch, okay, the hatched portion, okay, is called as area under the curve. That represents total quantity of the runoff during that period, okay. What is the total quantity of the runoff, okay. So during that period, okay, that can be taken from this, okay, the area under this curve, okay. So for example, if you have take a data of 1 year from starting from April and then to the April month of the next year, that is 12 months data. So during that time, what is the total amount of runoff? Runoff means what is the amount of the flow or the discharges available. That can be that information can be taken from this flow duration curve here, okay. So that is about the hydrographs as well as the flow duration curves, okay. So while solving the numericals or the problems, okay, we need normally they ask to calculate power developed from the water in kilowatts, okay, can be determined, okay. This is a formula to determine the power developed from the water, okay. So here this power is normally measured in terms of kilowatts, which is equal to W times Q times H, okay, divided by 1000, okay, which is multiplied by nu naught, okay. So what do you mean by Q? Okay, as I said before, it is a discharge. It is measured in terms of meter cubes per second, okay. So and then H is head available in meters, okay. So that is head available in meters, and W is the weight density of the water. Normally the mass density of water is measured in kgs per meter cube, whereas weight density, it is measured in terms of, or the units for weight density are newtons per meter cube, and then nu naught is the overall efficiency, okay. So these are the terms which are involved in order to calculate the power in terms of the kilowatts, okay. So in the problem what they do is, okay, in the numericals they would have given the efficiency and then they would have given the head, and then this is constant, we know that for the water, okay, 9.81 into 1000, so that is weight density of the water, and then only thing we need from the graph is Q, that is the discharge, that is mean discharge available over the period of time. That can be, okay, that data can be taken from this hydrograph here, okay. So once you take that data, other data are given in the problem, so that you can calculate what is the power which is developed from the water in kilowatts over the period of time, okay. So next we will discuss about the mass curves and unit hydrographs, and later with the numericals. So next we will discuss about the other topics, that is unit hydrographs and then the mass curves, okay. So here this is a graphical representation, I mean how this mass curve looks like, okay. So on the x-axis we have the time, on the y-axis we have a cumulative discharge, okay. What do you mean by cumulative discharge is, okay, if you start to calculate the discharge, okay, in an year, okay, if you start from the April, okay, so you imagine you have a 10 meter cube per second or for example, okay, so in the month of the April, okay, so in the next month you have 20 meter per second, okay, so you are going adding that the discharge, okay, from month to the month, okay, so that is plotted on the y-axis here, okay, so graph of the cumulative value of the water quantity against the time. Okay, this is the cumulative like a value of the water quantity, which is on the y-axis, that is cumulative discharge, and then on the x-axis we have a time. Okay, time can be in terms of the week or month. Okay, so hour, etc. So the integral curve of an hydrograph. Okay, this mass curve which represents the integral curve, okay, of a mass curve. Okay, so and then express area under the hydrograph from time to time. Okay, so the area under the hydrograph, okay, from time to time can be calculated with the help of this, the mass curve here. Okay, so this is about mass curve. Okay, so this is cumulative discharge on y-axis, and then the time on the like x-axis. Okay, if you plot that, you will get the mass curve. Okay, the last theoretical topic, that is unit hydrograph. Okay, so the definition of unit hydrograph is given here. The unit hydrograph may be defined as hydrograph which results unit runoff, okay, resulted from an intense rainfall. Okay, when you have an intense rainfall, okay, so that what is the discharge during that intense rainfall you have of a unit duration. Okay, so for example, if you have an intense rainfall during a 1 month, okay, that is a unit duration. Okay, you can also take it for 1 hour, okay, or 1 week. Okay, so that is a intense rainfall, okay, resulted from intense rainfall, and then of a unit duration and specific area distribution. You have to take a specific area where this we also call it as a catchment area, where this rainfall happens. Okay, so that is called as a unit, the unit hydrograph. Okay, I repeat this definition. The unit graph may be defined as a hydrograph which results unit runoff, okay, resulted from an intense rainfall. Intense rainfall means heavy rainfall of unit duration. Okay, the unit duration is, you have to take it in terms of months or hours or weeks, etc., and specific area distribution, okay, over the area, that means catchment area where the rainfall is happening. Okay, so that is called as the unit hydrograph. Okay, so next we will take up one problem, okay, based on these concepts, that is hydrographs, flow duration curves. Okay, and then to calculate the power, as we discussed earlier, so we will see that the numericals based on these concepts. So the last topic for today, this session, is about numericals. Okay, we will solve some numericals based on the concepts we have learned, that is based on hydrographs, flow duration curves, and then mass curves, and then the unit hydrographs. Okay, so we have taken one of the problem. Okay, the problem is like this. Okay, so here the runoff data of a river at a particular site is tabulated below. So this is a tabular column which shows the runoff data, or the volumetric flow rate of the river or a stream. Okay, so here we have like in one column, the first column is a month, that is a time. So here we have listed out the months. Okay, so for per month we have measuring the discharge. Okay, this is January, February, March, April, May, June. Likewise, June, July, August, September, it goes up to the December. Okay, so here in the second column we have a mean discharge per month. Okay, so here it is taken in terms of millions of meter cube, that is the unit of, okay, discharge per month. Okay, so that is millions of meter cube per month. Okay, for example, if you take the January, you have 40 millions of meter cube per month. Okay, that is in January you have the flow or the runoff, okay, of the river is 40 millions of meter cube per month. Okay, similarly February you have a 25 millions of meter cube per month. Okay, in a same fashion, okay, we have taken in the problem they have given us this data about the runoff data of a river. Okay, so it starts from January, February, and March, so up to it goes to the November and December. Okay, in the November we have 50 millions of meter cube per month. Okay, so and then in the December we have like a 40 millions of meter cube per month. Okay, this is the data they have given us in the problem. Okay, so what are the unknowns that we need to find out are, okay, the first one is draw the hydrograph and find the mean flow. Okay, this is the first like a graph we have to plot. Okay, so that is a hydrograph plot. Hydrograph we have to plot. Okay, so as we know, while discussing about the theoretical concepts of hydrograph, it is on the x-axis we have the time. Okay, here since the data is given in terms of the months, on the x-axis you have the months, on the y-axis you will plot this discharge, that is in millions of meter cube per month. Okay, so and then the second one they ask us to find out is also draw the flow duration curve. Okay, so flow duration curve is also a graph which is on the x-axis we take the time. So here like a time is in percentage. Okay, we start from 0% of time and then we'll go up to the 100% of the time. On the y-axis we have a discharge again, that is millions of meter cube per month. Okay, so that graph we have to plot. Okay, so in the hydrographs only we have to find out the mean flow, that is used for the calculation, okay, of the third sub question, that is find the power in megawatt available at the mean flow. If the head available is 80 meters, the head is given, head is always measured in meters, and overall efficiency of generation is 85%. Okay, the efficiency nu naught is given. Okay, so we have standard formula. Using that formula we have to find out the power available in megawatts. Okay, here they have given us the note. Okay, because we have the months. Okay, in some months we have 31 days, in some months we have like a 30 days. Okay, so in February we have a number of days are different. So here the note is given as, okay, take like days in a month as 30. Okay, all the months assume it has got 30 days. Okay, so that is the note they have given us. Okay, so coming to the first sub question, okay, that is draw a hydrograph and find the mean flow. This is the first sub question. Okay, I will name this as hydrograph. Okay, so what we have done here is, okay, so we have drawn a graph. Okay, so on the x-axis, okay, we have a months. Okay, so since hydrograph is a like a graph which is on the x-axis, we have a time. So here the time given, okay, in terms of the months, okay, start from January, February, it will go up to November and December. Okay, so we have on the x-axis we have plotted the months. Okay, how many months we have? It starts from January, it goes up to December, so we have a 12 months. Okay, I have taken the unit scale. Okay, so for that unit scale, like 1.5 centimeters or 1 centimeters probably. Okay, so this is January, February, March. Okay, so April it will, I have gone up to December. Okay, so I have only given the notations. Okay, J represents January and F represents the February, March, and so on. Okay, on the x-axis we have a time, that is in terms of the months. Okay, so on the y-axis what we have is, it is a discharge. Okay, so be careful about the units. Okay, it is millions of meter cube per month. Okay, that is a discharge we have. Okay, so here if you look at this data here, discharge like a least we have it in a May, okay, that is 0, and then maximum we have it in a September, that is 110. Okay, so that is 110 millions of meter cube per minute. Okay, so what I have taken is, here it is 0, I am gone up to like a 130, okay, like a millions of meter cube per minute. Okay, so and then like in the steps of 10 millions of meter cube per minute. Okay, here we have 0, 10, 20, 30, 40, 50, 60 and so on up to 130 we have gone. Okay, so obviously we need only up to 110 because the maximum flow available in the September is 110 millions of meter cube. Okay, so after this what we have to do is, we have to plot the graph. Okay, using this table here. Okay, so what happens, okay, in the month of January, how much we have a discharge here? It is equal to the 40 millions of meter cube. Okay, so where we are here in the x-axis, I am referring to this one, January. Okay, so this is 10 millions of meter cube. If you go up 20, 30 and then 40. Okay, in the January I have a 40 millions of meter cube per month. Okay, so what I do is, I will draw one line here. Okay, that will cover the whole of January month. Okay, so if I go to the next month here, okay, that is 25. Okay, here it is 40, the discharge is reduced. Okay, so here I have, this is a February month. Okay, this is a February, so I have 25. Okay, what I do is, I will draw one vertical line downwards. Okay, so now see, this is 0, 10 and then 25. Now it is coinciding with the 25. So throughout throughout this February year, I am drawing one horizontal line like this, okay. So that is about the February. If you come to the March, okay, again the flow rate or the discharge is reducing, that is 20, okay. So now we are here, okay, this is a March month, okay. So like I will draw one more line downwards, okay, about 5 meter cube per millions of meter cube, okay, per month it has been reduced, okay. So throughout the month of March I have a 20, okay, that is the discharge I have, okay, plotted there, okay. Similarly again come to the April, it has a 10 like a discharge, okay. So like see, this is a 0 and this is a 10, okay. Here this is a April month, in the April month I have a, okay, 10 as a discharge. So I will draw one horizontal line which covers the April month, okay. So and then up to here, okay. So after that we have a May, in that we have a discharge of 0. So what happens is this completely drops down, okay. This is a 0 discharge here, okay. So for whole of the month of May it is 0. Like this, okay. So again if you come to the, okay, June, okay, so now the discharge has increased, okay, that means it has gone up to 50. So now what I do is 50 is here, 0, 10, 20, 30, 40, 50. So if I take it here, okay, here it is, and then this is a month of June, okay. So I will draw one vertical line, okay, so up to this point, okay, and then this is the month of June, okay, I will draw one horizontal line like this, okay. So again similarly if we go to the July, I have 75, I have drawn, okay, this is a 60, 70 and 75 somewhere here, and then I will draw one horizontal line that will corresponds to the July month, okay. Similarly we have in August it is 100 and September we have 110, that is the highest discharge, okay. So in the August, this is the August month, okay. So this is corresponds to the 100 here, this is the 100 here, and then I will draw one horizontal line that will cover the 100, and then in the September I have a maximum discharge, that is 110 here, okay. So if you look at this graph, again after the September the discharge falls to 60, okay. So I will drop one vertical line, okay, up to 60 here, okay. This is a 60 here, okay. So that is the month of October we have a 60, okay. So and then in the November we have like a 50, and then in the December we have a 40, okay. So this is the 50, and then again we have a 40, and then I will drop down one line down there, okay. This is how you will plot the graph, okay. So what we have done is based on this given data, so we have taken on the x-axis as the months as the time, and then we have taken the unit scale, okay. On your graph sheet you can take 1 centimeter is equal to 1 month, okay, or 1.5 centimeter is equal to 1 month, okay. So and then the y-axis you can take a scale as, okay, 1 centimeter is equal to 10 millions of meter cube per month, okay. And then you have to mark all these values, like on the x-axis all these months, and then y-axis all the discharges, and then based on this table you have to draw this hydrograph here, okay. So this is how you have to draw like from the given data the hydrograph, okay. So one more thing they have asked in the question is find the mean flow, okay. What do you mean by the mean flow is you are going to add all the discharges in all the months. We have a 12 months basically, January, February, and then it will go up to November and December. So you will add all the discharges in all the month divided by 12. That will give the average discharge in an year, okay. So for that the mean discharge for the given data is calculated as, see here, 40 plus 25 plus 20 plus 10 plus 50, okay. 40 plus 25 plus 20 plus 10 plus 50, and then other discharge are July we have 75, August 10, September 120, 60, 50 and 40 respectively for the months of October, November and December, okay. So this is on 10, 60 plus 50 plus 40 divided by 12, okay. If you do that you will get the average discharge, okay. So like by simplifying this is, you will get it as 580 divided by 12, which is equal to 48.33. So this is millions of meter cube per month, okay. You can that just show it on a graph as well. So here we have 0, 10, 20, 30, 40, and then the mean discharge is about 48. So somewhere here you will get the mean discharge. I will draw one dotted line, and then I will show it as mean discharge, which is equal to 48.33 millions of meter cube per month. Okay, so that is a mean discharge. Okay, next we will see how to find out this the second unknown, that is also draw the flow duration curve. Okay, so for that what I do is, okay, so I will take off this rub off this one hydrograph. We need a basically table for that one. Okay, I will try to draw the table here. Okay, and then based on that, okay, we will draw the graph at this point. Okay, so now let us look at the flow duration curve. Okay, for drawing the flow duration curve, okay, so we know that flow duration curve is on the x-axis we have a time that is taken in a percentage, on the y-axis we have a discharge. Okay, so for that we need a table. Okay, so that table is shown here. So this table is written based on the data which is given in the question. Okay, from this data we have written this. Okay, let us analyze that table. Okay, how did we write that table? Okay, so in the first column we have discharge per month. Okay, this is millions of meter cube. Okay, so here from the lowest discharge to the highest discharge, I have listed out the numbers here. Okay, for example 0, so and then 10, the next highest discharge is 20, next is 25, that is in the month of February, and then we have 40, the next highest one, that is in the month of January, and then 50, that is in the month of November, again 60, and then 75, 100, and then 110. Okay, we have noted down all the discharges. Okay, so from the table given to us. Okay, so this is second column shows total months during which the flow is available. Okay, so for example, if you take the 0 discharge, okay, so minimum is zero discharge. Okay, it is, let us see this table and then take, okay, how many months the 0 is available. Okay, so if you look at this, everything is greater than 0. Okay, except this one, May. Okay, so that is also a 0 discharge we have. Okay, so that means to say all the 12 months we have a 0 discharge. Okay, is available. Okay, so 0 is available for all the 12 months. So I have written this as 12 here. Okay, how do you calculate this percent of time? That is 12 by 12. Okay, that means number of months the discharge is available divided by the total number of months. Okay, in the denominator always we have a 12 because we are calculating for the 12 months. Okay, so this is 12 by 12 into 100, that will give it as a 100%. Okay, next we will come to the 10 here. Okay, so where else? Okay, we have a 10 here. Okay, it is greater than 10 here in the January. February is also greater than 10. So and then we have in the March also greater than 10. Okay, so that means in the April we have a 10 discharge. Like where we get the discharge which is less than 10 is, okay, only in the month of May. Okay, so we need to exclude this, okay, from the calculation. Okay, so here we don't have a 10 minimum 10, okay, millions of meter cube per month discharge. Okay, so that means to say we have totally 12 months except this month, that is May month. That means 12 minus of 1, you will get the 11 months. That means to say, okay, 10 millions of meter cube per minute is available during the 11 months, okay, except 1 month. Okay, so that is the meaning of that. Okay, how do you calculate the percent of time? Okay, it is the ratio of 11 divided by 12. Okay, you will get it as 91.7, okay, million. I mean, it is a percentage of time. Okay, so next is we will take the 20. Okay, so in the April month we have a 10 and then the May month we have a 0. Okay, except that, okay, except these 2 months, April and May, all the other months, okay, the discharge is 20 and above. Okay, that means to say you have to exclude only the 2 months here. Okay, so that means this is 10 months we get the, okay, like a 20 millions of meter cube per month. Okay, except 2 months, all the other months we will getting a discharge. Okay, so that is why we are written it as 10. So it is the ratio of 10 divided by 12. You will get it as, okay, 83.3. Okay, that is the percent of time. So next we will come to the 25. This is a 25 here. Okay, so if you look at this data here, okay, so here in the March month we have a 20, that means 25 is not available here, and then in the April it is less than 25, and then in the May it is less than 25. Okay, except all these 3 months, that is March, April and May. Okay, all the other months we will get the discharge 25 and above. Okay, that means to say, so you have to take out these 3 months, 12 minus of 3, okay, that is equal to 9. Okay, this is a 9 months where you will get the discharge which is equal to 25 and above. This ratio is 9/12. That will give you the 75%. Okay. So next one is a 40. The discharge we have taken is 40. So here February month we have 25, which is less than 40. March we have 20, less than 40, and then April we have 10, less than 40, and then May we have 0, okay, less than 40. Except February, March, April and May, all the other months we have the discharge which is equal to the 40 and greater than 40, okay. So if you take the 12 months and then if you take out all these 4 months, okay, where the discharge is not equivalent to 40 or less than 40, so then you will get it as 12 minus of 4, that will be equal to 8 months you will get the discharge, okay, which is equal to 40 or greater than 40, okay. So this ratio is 8 divided by 12, you will get it as 66.7, okay. Next one we have taken is 50, okay, this is a 50 here. So like this, January 40 less than 50, okay, and February 25 which is also less than 50, and then March is 20 which is less than 50, okay. April and May we don't get the flow, 1, 2, 3, 4 and then 5. Again you have to look here, okay. December also we are not getting the flow, okay. That means 6 months we don't have a flow, okay, which is equal to 50 or greater than 50, okay. So in the 6 months we have a flow less than the 50, okay. That means to say 12 minus of 6, okay. What is that? You will get the 6 months, okay. So what is mean to say is, okay, so for the 50 discharge, okay, 50 millions of meter cube per month, okay, discharge is available, okay, so only for the, okay, 6 months here, okay. So that is the time percent is 50, okay. Next we will take it as 60, okay, all these, okay, January it is less than, okay, February less than 60, March, April, May and June all are less than 60 here, okay, and then here also these 2 months are less than 60, okay. That means only in July, August, September and October you will get the discharge as 60 or greater than 60, okay. That means only the 4 months you will get, okay. So that means 12 minus of 8 months, okay, you will get it as 4. This ratio is 4 divided by 12, that is 33.3, okay. So and then 75 similarly, this is a 75 here, okay. So that is all these months you don't get the flow which is equal to 75 or greater than 75. Here also these 3 months you won't get, okay. So only during 3 months you will get the 75, that is 3, here 3 divided by 12, 25, okay. 100 is, okay, only August and September you have a flow of 100 and greater than that, so that is why this is 2 divided by 12, you will get it as 16.7, okay. Similarly you have 110 is available only during the 1 month, that is during the September month, so this is 1 divided by 12, you will get it as 8.3, okay. Based on this we will draw a flow duration curve. After plotting this graph, okay, that is necessary for flow duration curve, so which is based on the data which is given in the problem, okay. So we have to plot this graph, that is, this is a flow duration curve where on the x-axis we have a time in percentage, on the y-axis we have a discharge. Remember this discharge is in the units of millions of meter cube per month, okay. So in order to draw that we need for example, so here in the x-axis it is a percentage of time, okay. This data we have on the x-axis, on the y-axis we have a discharge, okay, this one here, okay. For example, the first reading is the discharge is 0, this is here, this is 0, 10, 20 and then this is 0 and then this is available for 100% of the time, okay. I will have marked 1 point here and then the second point is 10 and then the percent of like a time is 91.7, so we have 0 here and then 10 millions of meter cube per month, okay. It is available for 91.7%, okay. This is the second point. Similarly the third point is 20, that is millions of meter cube, that is a discharge 83.3, okay. This is 0, 10 and then 20, this is available for 83.3% of time, okay. So this similar way you have to plot all these points here, okay. So this is 25, 40, 50 and 60 and 75 and then last points are like you have 100, this discharge is available for 16.7, okay. So for example you have a 100 here it is, okay, and then it is available for 16.7% of time, here is this point, okay. The last one is, okay, it is 110, okay, which is available for 8.33 somewhere here approximately, so that is also plotted, okay. So these are the discharge, okay, that is the y values and then this is the percent of time, okay, these are the x values, okay. So after like marking all these points, okay, you have to join them with a smooth curve. something like this. Okay, so here it is also joins at this point 100 because at zero discharge is available for whole of the time. Okay, so this is the flow duration curve. Okay, so and then the third sub question that they have asked us is now to find out average megawatt energy available. Okay, the formula to find out the average megawatt energy is nu naught into W into Q into H 1 divided by 1000 megawatts. Okay, so here the various parameters involved is nu naught is the efficiency that has been given in the problem, that is 85%, and then W is the weight density of the water, that is 9.81 into 1000. That units for that is newtons per meter cube, and then Q. Okay, Q is very important factor here, or a parameter that we will find from the hydrograph. Okay, as I was explaining, it is a summation of all the discharges of all the months divided by total number of months. Okay, we got it around 48.33. Okay, so this is the Q here. Okay, so the thing is here you need to substitute that Q, that is discharge, in meter cubes per second. Okay, so you have to convert this 48.33 millions, okay, of cubic meter per month, okay, into meter cube per second. How do you convert that? Okay, so 48.33, okay, millions. Okay, millions is 10 to the power of 6. Okay, so like 48.33 into 10 to the power of 6 divided by, okay, we have a month in the denominator. Okay, so that means this 30 represents, okay, so number of days, and then 24 number represents, it is a number of hours per day, and then which is multiplied by 3600 seconds. Okay, so that is number of seconds per hour. Okay, so this is how you convert this month into the like a seconds. Okay, in the numerator now you have meter cube, in the denominator you have in terms of seconds. Okay, so those things have been substituted here. 48.33 times 10 to the power of 6 divided by 30 into 24 into 3600, which is multiplied by 1 by 1000. Why this factor is, we will get this in kilowatts. They have asked us to find out in megawatts. Okay, so that 1 by 1000 factor, okay, converts kilowatts into the megawatts. Okay, so if you simplify this values here, you will get this answer as a 12.4 megawatts. Okay, so this is about when the data is given, okay, runoff data is given for the river. Okay, so then how to draw the hydrograph as well as flow duration curve and the energy available in terms of the megawatts. Thank you.